Hi, welcome to this video introducing enhancements made on containers management in the new 10.16.1005 release. During this video, we'll cover the following topics. So first, an overview, then we will look at the use cases and then go through the details and caveats. We will then see the configuration and the troubleshooting.
Okay, so let's start with the overview. So AOS-CX 10.16.1005 brings several enhancements to the container support into AOS-CX. So first, and maybe one of the most important enhancement is the support of Docker as container infrastructure. So it means that we do not have to rely anymore only on Container Manager and runc. We also have now Docker, which has been integrated into AOS-CX to get more capabilities, and we will see that in a future slide. The image size has been also increased on several platforms. The HPE 8225, 9300, including the S version, and the 10K. We also have a persistent storage support for container applications, so it means that now a container can store and read files which are located and hosted outside of the container itself. We can now also start and stop a container, and we also have some hardening items for the container. So for this last part, so this is more of backend things, so we will not necessarily cover those items, so the container hardening during this TOI, but be aware that we also have hardened the container infrastructure. So all those new capabilities allow us to answer to more use cases. So why Docker? So Docker has been integrated into AOS-CX in order to benefit from several things. So first, it's comprehensive ecosystem. So Docker being the most widely used container infrastructure on the market today, it has a very vast and very large ecosystem. So it's very beneficial for AOS-CX also to benefit from this comprehensive ecosystem. It also have a very large community and support. So in order of development for the containers, it's also important to be able to rely on this community and the support of this community for future development. And also to benefit from advanced features such as built-in orchestration, better networking, and robust security options. And so all those benefits ensure improved performance, scalability, maintainability, and future-proofing for the Container Manager feature. So aside of that, some notes. So as of AOS-CX 10.16.1005, Docker version, which is in use in AOS-CX, is the version 25.0.2-C, so the community edition. Docker Compose is not integrated into AOS-CX, and Docker on AOS-CX cannot be orchestrated by third-party solutions like Kubernetes, OpenShift, or Docker Swarm. So let's discuss about the use cases now. So the integration of Docker as backend container manager doesn't change how users have to manage their containers as well as initial use cases already demonstrated in previous TOIs. But the support now of persistent storage brings some additional capabilities, offering the ability, as an example, for a container to store its data and being able to retrieve them if the container is restarted. So it allows to support additional use cases where data persistence after a container restart or a device restart is required. So it includes the following type of files. So the configuration files of the container, as an example, but also some data like, as an example, some temporary files like leases files when we have a DHCP server hosted on the container, some web server files and content, and also some video files. In the following slides, we will see some use cases where persistent storage brings additional values. So for each use cases, you will have the CLI snippet showing how persistent storage can be configured and the additional value that it brings. So let's start with network monitoring container. So in that case, we host a Prometheus monitoring container to collect metrics for network devices. So in that case, persistent storage allows to store Prometheus data and the config files. We also have the API gateway for network automation. So in that case, we deploy an API gateway to provide a centralized API interface for network automation, enhancing internal CX capabilities. And so for this use case, persistent storage allows to store the web server config files, but also some web server content. We also have the DHCP server for network edge. So in that case, we want to deploy a DHCP server container at the network edge. And so for this use case, the persistent storage allows to store the configuration files of the DHCP server, but also all the leases which are stored in different files hosted on the USB key. The remote site file management. So we want to deploy a centralized file management solution that could work offline and synchronize when connectivity was available without deploying dedicated servers at each location. In that case, persistent storage allows to store configuration files and obviously the user space. And finally, the manufacturing edge web services. So we want to provide local web-based dashboards and documentation access at remote location without impacting production networks or requiring additional infrastructure. For that use case, persistent storage allows to store web server files and content, as well as SSL certificates. And the last one, so edge computing in the case of a retail branch. So we want to deploy AI-based video analytics at remote branch locations without adding server hardware at each site. For this last use case, persistent storage allows to store video files. So let's move on now with the details. So before AOS-CX 10.16.1005, as you already know, we have three main components. We have the process which is called container manager, which is the main process that manages the container lifecycle in CX. We have runC, which is a container runtime used by container manager to deploy containerized application. And we have the container network interface, which is a set of plugins used to set up the network connectivity required by container applications. Aside that, we also have the container network, which is a network dedicated to containers and bringing them connectivity. And obviously, we have the OVSDB, which is the AOS-CX system database. But with AOS-CX 10.16.1005, we now have three more components. So we have the Docker engine, which is now the main process that brings an interface between CX and the container manager and the container infrastructure. So this process is responsible for loading, starting, and passing configuration into the running container. And Docker engine uses containerd, which is a container runtime used by Docker to manage the container lifecycle in CX. So containerd will interact with runC as the underlying low-level runtime, and it works in conjunction with a smaller component, which is named containerd-shim, which will be used to manage the communication between runC and containerd. And so all those three components, so Docker engine, containerd, and containerd-shim, are developed and maintained by Docker. Aside that, we also have a new component, which is Docker Network Bridge plugin. And so the Docker Network Bridge plugin allows the configuration of bridge networks for containers deployed by Container Manager to enable inbound and outbound connectivity. So as of AOS-CX 10.16.1005, so the implementation of Docker as backend of container management doesn't change anything on how containers are imported and created. So it still requires to create the image on a remote server, to save it as a TAR file, and to import it using a remote HTTP server. So what does it mean? It means that there is no way to create a container by importing the image directly from Docker Hub. So Docker Pool won't work on AOS-CX. HTTPS is not supported, but in the meantime, some changes have been implemented regarding how network and container state are managed in the backend. So before AOS-CX 10.16.1005, images were automatically downloaded and containers were automatically started as soon as the image was downloaded and validated by the system. But now with AOS-CX 10.16.1005, one of the first improvements coming with this release is the ability to start and stop a container. So by default, if a container is not enabled when created, as you can see on the left-hand side of that slide, AOS-CX won't even download the image. So you can see here that we are creating a new container, which is named app2. We are configuring everything, so the image location, the network, and the mount as well, but we do not enable the container. So it means that even with this configuration, if we do not enable the configuration, the image is not downloaded because the container is disabled. So we have to enable the container to start download of the image, and so to start the container as well. So as I mentioned, so containers now must be manually enabled to be started, which means also that they can be stopped when it is required. So let's take this example. So we have a new container, which is app1. So if we enable it, we can see that the status is now operational. But if we do a no enable, the container is now administratively disabled. And so that's an enhancement with this new release, because before AOS-CX 10.16.1005, if we wanted to stop a container, we had to remove the container. So in terms of network connectivity, an important change has been made with AOS-CX 10.16.1005. So before this release, a container could have been attached to several VRF. Starting with this new release, each container can be attached to only one VRF. So in case a container is attached to multiple VRF, an error will occur and the container won't start and a specific error message will be displayed. So as you can see on that CLI snippets, we can see here that the container app2 has been attached to two different VRF, and so in that case, the container status is set to configuration failed, and the reason for that is container has more than one network VRF. So on AOS-CX, the support of persistent storage has been implemented using binding mount instead of volume. So why binding mount instead of volume, while this latest is maybe the most well-known way to store data with containers? So volumes are fully managed by Docker. So in that case, a new directory is created within Docker storage directory on the host machine, and Docker manages that directory's content. On the other side, mounts allow end users to choose and specify the source path on the host. So as the support of persistent storage relies on the usage of a USB key, it is mandatory to be able to store files outside of the Docker storage directory. Another key point is the fact that as of AOS-CX 10.16.1005, and with the introduction of persistent storage, a dedicated directory will be automatically created on the USB key to store files used by containers. So container mounts will be now placed under the internal storage top-level directory on the USB key. So this top-level directory will be fully created and automatically created by the system. So if the directory does not already exist on the USB key, it will be automatically created by AOS-CX. As well, every file update must be done under this new directory. So there is no symlink between /container and /internal storage /container. So as you can see on the snippets, so first, before we are creating a mount, we only have the directory container with two subdirectories and with some file within each subdirectory. As soon as we create the binding mount, we have a new directory which is called internal storage, and within this directory we can find a new directory which is called container with the two subdirectories that we have already created on the USB key. And the content of internal storage, container, and each subdirectory is strictly the same than the one we had previously using container by itself. So starting with AOS-CX 10.16.1005. only a USB key is supported as external storage. So to avoid too many IOs on the SSD, and so to lower its MTBF, the USB key is the only storage which can be used as a source when we are creating a binding mount in the container configuration. USB key must be formatted using the format ext4. So if it's not done using a laptop, this can be done directly on the switch using the CLI command USB format expanded storage. AOS-CX will look for a directory called container on the USB. So it will be used as the root path. So it means that all files and directories having to be mounted in the container must be located within this directory container. And the last point is the fact that there is no limit to the number of mounts which can be attached to a single container. Docker has no limit for the number of binding mounts, so there is no limit which has been enforced in AOS-CX. To use a USB key to manage persistent storage, several rules must be followed. So first, the root path in the USB key must be USB:/container. So it means that when we are doing the container configuration, if we put the source path as /, it means on the USB key that this is before the mount, it is USB:/container. And after the mount, it will be USB:/internal storage/container. If we use another path like /app/data, it means that we are targeting USB:/container/app/data before the mount. After the mount, it will be USB:/internal storage/container/app/data. The second point is the fact that the source path must already exist in the file system. It won't be automatically created if specified path does not exist on the USB key. So as you can see here, we are targeting as a source the path as /app/data, but this path does not exist on the USB key. So as a result, we have a container status with configuration failed, and the reason for that is failed to configure mount to. The path does not exist in the source file system. Finally, binding mounts can be modified without having to disable the container first. So in the backend, container will be stopped and restarted with the new binding mount. So if you look at that, if we look at those snippets, you can see here that we are modifying the destination path. And if we look at the log, you can see that the container has been stopped and disabled. And then once it will have created the new binding mount, it will be automatically enabled and started. Regarding now the platform support. So Docker and container start-stop capability are supported on all platforms starting with the 6300, excluding the 6300L, which does not support containers. On the other side, persistent storage is supported only starting with the 8100. And finally, the image size has been increased to 1000 megabytes on 8325, 9300, including the S and the 10K. It has to be noted that 8325 includes 8325, 8325H, and 8325P. Okay, so now let's move forward with the best practices. So first, it is recommended to enable a container only once all container configuration has been done. So as you can see in this CLI snippet, so we are creating a new container. So we are configuring the image location, everything related to the network, the different restrictions like CPU and memory, the different environment variables, and then we enable the container. We did not enable the container at the first step. So we are just configuring everything first, and then we enable the container. It avoids the container to be restarted multiple times if it is enabled first. Then you should also disable a container first when its configuration has to be updated, as you can see on this snippet. So we want to modify the different restrictions like CPU and memory. So we first disable the container, we are doing the modifications, and then we re-enable it. And we also have to disable a container first when we want also to update the image. So as you can see in this CLI snippet, so we first disable the container, we change the image location, so to get a new version of the image, and then we re-enable the container. Then regarding the persistent storage. So first, always unconfigure maintainer mounts before unmounting or removing USB devices. Indeed, if the USB device is unmounted or removed without unconfiguring the container mount, container functionality is not guaranteed. Also, backup important container data regularly. And in regard of the performance management, use a USB 3.0 key for better performances and minimize write operations to USB storage. Then, if you encounter an issue with a port already in use, do not forget to remove the old configuration line, otherwise the container will remain in a failure state. So as you can see here, so we are in our container app 2, we are adding a new port mapping. So we want to map the host port 8082 to the container port 80, but because we did not remove the previous line, which mapped the host port 8081 to the same port 80, so we have two lines, so two different host ports, which are mapped to the same container port. So it means that the container status is now in deploy failed. So we have to remove one line in the network configuration context, so we remove the previous host port, so 8081. So it means that only one line remains in the network configuration context. And in that case, because we only have one host port mapped to the container port 80, the container status is now operational. Okay, so now let's discuss about the configuration. So as you already know, the minimal mandatory configuration is the image location, which is a URL to be used to download the container image. As an option, we can use the Allow Unsigned option to import images which are not signed by HPE and the VRF to reach out to the remote repository. If it's not specified, the VRF default will be used. All other items, like the network or the restrictions, are not mandatory to get a container up and running. Aside that, AOS-CX 10.16.1005 brings two new commands. We first have enable, which allows to start a container, otherwise the container will remain disabled. And so obviously the no enable command will disable the container. Then we have mount, which allows to configure the persistent storage, which will be used to create a binding mount on the container. In this new context, a source and a destination must be specified. As stated in previous slide, as of 10.16.1005, the source must be a USB key. On the other side, we also have a REST API. So coming from previous AOS-CX versions, we already had two APIs to configure the container. So we had the first API to create the container, so to specify the image location, the image on the VRF, and so forth. And we had another API to configure the network attachment of the container. With 10.16.1005, since we now have the binding mount and so the persistent storage support, we now have a new API which allows to create a container's binding mount. And so using this kind of payload, we can now create the entire configuration of a container, including the persistent storage. So let's move on with troubleshooting. The first thing for troubleshooting containers is to check the infrastructure by itself. So if we focus on the containers themselves, we need to check the HTTP server reachability through the VRF specified in the image location command. We also need to check that the remote HTTP service is online, to check the container's image can be downloaded using the URL specified in the image location command, and also to check the VRF specified for containers connectivity. Now, regarding the persistent storage, we need to check the USB key is formatted using ext4. We also need to check that the USB key is correctly mounted in AOS-CX. We need to check the directory container exists on the USB key. And finally, we also need to check that the source already exists on the USB key. We obviously have two CLI commands to check containers that have been introduced in AOS-CX since 10.12. Show run container, and we can see here that we have some new lines for the binding mount, and show containers also with a new set of lines for the personal storage. In the device events and debug now, we can still rely on show event, okay, with the ability to filter using container mgr as a daemon, but also the debug containers, all or events, and we can use a terminal monitor to see in real time the different logs coming from the debug. And finally, you can also get access to different information using a diag dump, which includes Docker inspect, Docker network inspect, containers logs, and bridge information.
So this is it for this video. Thanks a lot.